In this session, you're going to be building on some of the basic skills that you have learned about in statistics in order to look at variance and standard deviation, which are some important concepts as far as statistics is concerned. So, in this scenario, we are going to imagine that you and your friend have been out with some dogs, perhaps doing some dog walking to earn a little bit of extra money, and you've decided to measure the height of the shoulder of the dogs from the ground. So the heights are 600 mils, 470 mils, 170 mils, 430 mils, and 300 mils. And what I want you to do to start off with is to find the range, the median, and the interquartile range for these dogs. So let's have a look at how you got on. The first thing you should have done is rearrange the data in ascending order. So if we have a look, this is the data rearranged for ascending order. The range then, very straightforward, should just be the largest value minus the smallest value, which gives you an answer of 430 millimeters. The median, to find the median, we want to find the n plus 1 over 2 result. So here n means the number of pieces of data. So if we've got 5 pieces of data, 5 plus 1 is 6 divided by 2. So we want the third result. Once we've put them in ascending order, the third result can be seen to be 430 millimeters. The interquartile range then. So the interquartile range can be calculated by subtracting the lower quartile, Q1, from the upper quartile, Q3. Remember, to find Q1 then, it is the n plus 1 over 4th result. So again, here n is 5, there are 5 dogs. So 6 divided by 4 is the 1.5th result. So this is my first result, this is my second result. I therefore average the two and I get 235 millimeters. Q3 similarly is just 3 times the lower quartile. If this is 25% or the 25th percentile, this would be the 75th percentile. So I just multiply this by 3, which is all I've done here. And if I do that, I want to find the 4.5th result. So again, similarly, I want to average these two results here, and I get 535 millimeters. The interquartile range then is subtracting Q1 from Q3, leaves me with 300 millimeters. The problem with these two measures, both the range and the interquartile range, is that your measure of spread is only based on 2 data values, so it's not a particularly sophisticated measure. In order to try and make our measure more sophisticated, we're going to augment it by using a value which incorporates, in some capacity, all of the values, and that measure is variance. So variance is a measure of spread which combines all of the values in a data set. The variance is the arithmetic mean of the squared differences from the mean value and can be represented by this formula. So we're going to have a look at this, break this down in a moment, but just to draw your attention at this point to the fact that there are 2 types of variance. One is called the population variance, which is what we're going to be looking at here. So we've taken all of the data in the population. It is also possible to calculate the variance for a sample, but we are only concentrating on the population variance here, which is all of the data that we've got. So let's try and have a look at this and break it down into something that we can get our heads around. We've said then that variance is the arithmetic mean of the squared differences from the mean value. So let's start off by working out what the mean value is. That should be quite straightforward. Here are our 5 heights of the dogs. Add them up, divide by 5, yielding an average height of 394 millimeters. The average then represented on the diagram by this green line here. The next thing we're going to do then is look at the arithmetic mean of the squared differences from the mean value. So let's start off by looking at the distance from the mean value for each of these dogs. So we can see these ones are all higher than the mean, so they've got a positive difference, and these are all lower than the mean, so they've got a negative difference. If we added these up, those would counteract to get 0, which isn't particularly helpful. However, by squaring these differences, all the numbers are positive, which gives us something to work with. So we square all of these together, and then we find the arithmetic mean of those squared values. So each of these differences we square and then take the arithmetic mean of these values, which yields a value of 21,704. Now that is a very high value, and typically we would interpret that in terms of standard deviation. Once you've found the variance, it's very easy to calculate the standard deviation, as it is just the square root of this value here, the variance. So that's the theory. Let's have a look now at how we can use our calculators to do this. So in this instance here, I've put height and frequency as my two columns. They are in ascending order here. I can then use the TI-Nspire to calculate this. I've only got one piece of information. That piece of information is the height of the dogs. The second column is the frequency. So I'm looking at one variable statistics. Number of lists is 1. I just click through that. Select, don't type in, but click the button in the center of the control pad and select height and frequency and click OK, and you'll be taken to this column. Remember earlier we talked about two different types of variance. We looked at a sample variance and a population variance. Now the S here stands for sample. We're looking at the population variance, so we're going to be looking at this segment here. This answer here is actually the standard deviation. So your TI-Nspire will give you the standard deviation, which typically is what we use anyway, as I said. So this is the standard deviation. If you were actually asked to calculate the variance, you would simply square this number here. So this is the square root of the variance, which is called the standard deviation. Standard deviation is the square root of the variance. We can see there that if the population variance here, sigma squared, this is the sum of the square of the difference between the data points and the mean, and then we're just dividing that by the number of data points. So this is the arithmetic mean of the squared differences from the mean value, and then the population standard deviation is just the square root of that. In terms of what it looks like graphically, if we have a low standard deviation, it means the typical spread from the mean is quite narrow or low compared to a high standard deviation, in which case a lot of the data would be further away from the mean. So low standard deviation characterized by data points which are close to the mean, and high standard deviation is characterized by data which is spread out over a large range of values. So give you a chance to have a go at a question now. 30 farmers were asked how many farm workers they hire during a typical harvest season. Their responses were listed below. So what I want you to do then is to calculate the standard deviation and variance for the farm workers they hire during a typical season. Here's our data then laid out like this. We've got each of the categories, so the number of workers and the frequency which they occur. We can put this into our TI-Nspire. You can label these W and F or whatever you want, X and Y, as long as you remember what they are. So again, the only piece of information we've got here is the number of workers. The second column is frequency. So we're looking at one variable. Statistics. Number of lists is 1. Our X is workers, and the frequency is frequency, or whatever you've called it. Throw that into our TI-Nspire, let it churn out the numbers, and you can see then here that the standard deviation, remember it's the population standard deviation, is going to be 2.25. So typically the number of workers is 2.25 from the mean value. If we wanted to calculate the variance, we would then square that, So we can see that this is the standard deviation, this is the mean, and we could calculate the variance by squaring it.